Okay, so we'll get started. My name is Chris Peterson. I am the Chief Information Officer at the Assay Depot, which is a company right up the road here. We are a Rails shop, and we host our website on EC2. So I thought that, this being the Ruby group, EC2 would be a good topic to talk on. So what is EC2? It stands for Elastic Cloud Computing. What does that really mean? A lot of buzzwords in there. Essentially, if you boil that down to the nuts and bolts, it means you have the ability to provision a server inside of Amazon's data center. With a call to a web service, you can provision your own VPS for your own personal uses and make use of Amazon's infrastructure. You can do all this by paying for those services by the hour, which is sort of a transition from buying your VPSs by the month or buying your hardware and installing it in your own data center. So what do you need to know to use EC2? The first thing you need to know is you need to know about images. And if you're familiar with virtualization, you're probably familiar with images. An image is basically a fully configured computer, OS installed, configured exactly how you like, packaged up into a file. You take that file, you register it with Amazon, and you can run that computer anytime you want on Amazon's infrastructure. What you get when you run an image is an instance. And the instances are really the core of EC2. An instance is the basic unit of computational resource available through their service. An instance is your VPS. An instance is what you get charged by hourly. There are three different types of instances. They're small, large, and extra large, and they're priced accordingly. Instances are really interesting. They really turn the idea of computational resources on their head. As opposed to buying two physical servers when you go to set up your system, so you have a production server and staging server, you can just you can set up your image with EC2. You can run it. You can run it as your production image, and if you need to test, you can run that same image, be sure that it's configured the exact same way as your production server, deploy to it, and test. And to do that, you've paid 10 cents an hour to test your application, as opposed to paying for a whole new server, paying for a data center, worrying about rack space, worrying about power. It also gives you the ability to scale. So, as opposed, if you hit the front page of TechCrunch, like a few of you have, you don't have to worry about going out and buying physical hardware. You don't have to worry about, paying for new VPSs by the month to scale horizontally. You can simply, with a call to a web service, provision new machines, as many as you want. From my perspective, and probably from most of your perspectives, Amazon has unlimited computational resources. We're not going to exhaust those resources with our website. At least I'm not. So it really turns computing on its head, where you can buy these resources by the hour inside of Amazon's data center. You don't have to manage it; they manage it for you. If you understand images and you understand instances, that's really the core of EC2. If you understand those, you can use EC2 to deploy your Rails application to. You can make use of just about all the functionality. But they do provide other functions, such as security groups. So if I have a data center and I put in two servers, I can physically walk to that data center. I can physically buy a piece of hardware called a firewall. I can put it in there. I can plug it in, and I can be sure that my servers are safe. Security groups give you basically the same functionality. You can think of a security group as a virtual firewall that you can provision and configure with a web service. With a security group, you can open up ports. You can define what protocols are usable on those ports, and you can find what subnets requests can be from on those ports. You can have as many security groups as you want. You can imagine having a database security group that's not accessible at all. Then you could have, except from your web security group, which runs all of your web instances. And your web instance, or your web security group, would be accessible on port 22, port 80, and port 443. So it gives you as many options as you want to configure the security of your instances. And the security groups are free. So you pay for the instances, but you can secure them however you want for free. Another benefit of using EC2 is what they call availability zones. Now, Amazon is a huge company. They do a ton of traffic. They've got data centers all over the world. I'm assuming that. EC2 exposes that infrastructure to you. So when you launch an instance, you can specify where you want that instance to run. So currently they've only opened up, to my knowledge, the East Coast of the United States, and they've got 3 data centers there. And when you launch your instance, you can launch it in any of those data centers. I'm hopeful that in the near future they'll be opening up other regions. If you want to have, one server in Asia, one server in Europe, one server in the United States, you can do that. So availability zones give you the geo-redundancy that Amazon has at, basically for free if you're already running instances. Now this is one of my favorite features of EC2. One of the major criticisms that's been leveled against EC2 is the ephemeral nature of their instances. So when you bring an instance up, it comes up in the state that the image was in when it was bundled. And it's a new computer. So that means that your storage is ephemeral and your address is ephemeral. We'll touch on the storage later, but right now we'll just talk about the addresses. So if every time you bring up an instance, you get a new IP address, how do you map a DNS entry to it? It used to be that every time you brought one up, you'd have to go to your DNS server, you'd have to change the record, you'd have to have a short time to live on it, and it's really not an optimal solution. So within the last couple of months, Amazon introduced the idea of elastic IPs. And an elastic IP is an IP address that you can allocate to your EC2 account. You can allocate up to 5 by default, and more if you need them are available through Amazon. And those are static IPs. You can use those. You run an instance, and then you just apply that IP to the instance, and immediately it's accessible from that IP. So you use your DNS entries to point at your elastic IP, and then you have the flexibility of pointing that elastic IP at any of your running instances. Like I said, this solved one of the 2 major complaints that people have with EC2, which was the changing addresses and the persistent storage, which I'll talk about later. Just real briefly, I'm going to talk about 2 more features that I haven't personally used. One of them is RAM disks. So Amazon announced that they now support RAM disks. And from that, I assume that means they didn't support them before. But like I said, I haven't used them. So being a talk on EC2, if you want to use EC2, be aware that this functionality does exist, but I haven't personally tested it myself. Likewise, for user-selectable kernels. So EC2 is, basically it's for Linux. I've heard, scattered reports of people running other things on there, but just use Linux. And when you launch your instance, you have the ability to change the kernel that it's running. So again, it's not something that I've personally tested, but the ability is there if you need to change the kernel. And that is basically the existing feature set of EC2. That's, from a high level, those are the capabilities that EC2 gives you today, right now, if you went and signed up. But like I said, we haven't really touched on the problem of ephemeral storage. So if you have an image, you bring up an instance of that image, and you have it up running for a week, and you're doing database writes to it. Database write. You kill that instance, you bring it back up using the same image, all of that is gone. So what good is unlimited computational power if you can't store the results of that computation? The way we've solved it at the depot is by having a very robust backup strategy. One of the nice things about EC2 is that communication between EC2 and S3, their storage network, is free. So we are continually backing up our data. We have a very well-tested backup solution, a very well-tested restore solution, which has actually turned out to be very nice. However, Amazon is solving it in another way. So they are introducing in the next couple of months, it's going to be going into beta, what they're calling persistent volumes. Persistent volumes are essentially a virtual hard drive that you can provision with a web service call, and it is associated with your account. And just like you can apply an elastic IP to a running EC2 instance, you can attach a persistent volume to a running EC2 instance. And then you can mount it just like you would a normal hard drive. And that is a low latency solution, and it's long-term storage. So Amazon claims that you'll be able to run your production database off of these persistent volumes, which I'll believe it when I see it, but I'm very hopeful. And they're long-term storage, so you probably still want to be backing it up to S3 just as a good practice. But persistent volumes and elastic IPs really solve the 2 biggest complaints that have been leveled against EC2, which is the ephemeral nature of the storage and the ephemeral nature of the IP addresses. And that really covers the high-level capabilities that EC2 gives you. What does that mean to us as Ruby developers? Is there anything that we can use to automate, stuff like that? There's a number of projects out there. I'm just going to briefly talk about 2 of them. The first one is a gem called Amazon EC2. And the Amazon EC2 gem exposes, as near as I can tell, about 98% of the functionality that is exposed via EC2. The only thing that I haven't been able to do with it that I can do with the command line tools is list the availability zones, which maybe it's just because I couldn't find it in the documentation. I'm not sure. Another project that is related to Ruby and EC2 is a project called EC2 on Rails. And this is an interesting project because it comes with a pre-bundled EC2 image for you. And the bundled image has Apache already installed and configured. It has Ruby. It has Mongrel. It has MySQL. It's configured using the recommended setup from Coda Hale on his blog. It's called Time for a Grown-Up Server. It's a very nice setup. And it also comes with a set of Capistrano recipes. And these recipes can be used to immediately deploy to your running instance. They can be used to back up the database. They can be used to restore the database. It's a nice suite of tools. In fact, we originally used it at the depot as our deployment strategy, and we had to move away from it as we had to customize our image more and more. But it's a very nice solution. If you're just getting into EC2, it's a good place to start. And really, that's about the end of my talk. I do have one more thing I want to say, though. I realize that these slides are very simple, and they're intended to cover the high-level capabilities of EC2. They don't really give you the nuts and bolts, the actual commands you're going to need to run to interact with EC2. So my original plan was to have the slides and have a 2 to 3 page cheat sheet that I would distribute that would get you up and running. When I started to write that, it immediately became a 20-page ebook. So it's done. It's ready, and I will make that available probably on our blog tomorrow, and I'll post a note to the group with, it lines up the documentation for the command line tools with the documentation for the Amazon EC2 gem, and it gives you, some pointers on how to get set up and up and running. So hopefully people will find that useful. And with that, I'll take any questions you might have. It's a web service call. I haven't used the web service directly. I've used the web service through Amazon EC2 Gem, and I've used it through the command line tools. It's essentially, I forget the exact command off the top of my head, but it's like EC2 run space. You give the AMI, and AMI is the ID that Amazon assigns to your image. So you tell it what image you want to run, you tell it what size you want, you tell it optionally an availability zone and a kernel in it. It's off and running. Creating an image is a bit more complicated. I have a blog post on it. There's a separate suite of tools that you install, and there's a bundle command, and that will bundle a running image from within that image. So there's a number of basic images that are available. So we took, I think, I want to say Ubuntu 6.10 image. We took that, we customized it for our needs, we installed all of the EC2 suite on there, and we configured it with our support system, we configured it with Solar, we configured it with everything that we needed to run our system. You hit the bundle command, there's a separate command to upload that to S3, and then there's a final command to register it, at which point it gives you an AMI, and you can use that AMI to run instances of that image. I believe you can do it locally, but I haven't tested it. That would be something fun to test, but I haven't tried it. So. Yeah, one of the other nice things about doing it on EC2 is it's already right there, and the transfer to S3 is free, which is where it's going to ultimately be stored anyway. So, but you do have options. Cliff? The VPSs, they don't really scale up. Each VPS is a set amount of computational resource. The small one is roughly equivalent of a 1.7 gigahertz single core machine with, I want to say, somewhere in the 1 3/4 gigabytes of RAM. The bigger instances that's a 32-bit instance. The bigger instances are 64-bit and are significantly bigger. The way you really scale is you scale horizontally. So if you need more than the biggest instance, you want to have your app be able to be spread out across multiple machines. And you can create as many of those machines as you want. WeoCeo, WeoGeo, there's... There's another project I'm not as familiar with, but I think it's called Scalar, which will do something similar, but it's not hosted. I think you run it yourself, but don't quote me on that. Yeah, RightScale is a company that'll manage that for you. I think last time I checked, maybe like $500 a month or something like that. Yeah. No. To actually bundle the image and. Yeah, it's a three-step process. After you go through the entire process of getting your image set up exactly how you want it. Well, you have root access to your VPS. You set it up exactly how you want it. If you want, Image Magic, you put it on there. If you want Nginx. The way we did it was we took an existing AMI. Amazon provides a number of them, and you can get a Red Hat AMI or an Ubuntu, or if you're Rob, you can get a Gen 2 AMI. That's how we did it. We started with a bare bones, stripped down Ubuntu image, and then we installed. The AMI is it's a string. It's an identifier that identifies the instance, that identifies the image to Amazon. So when you go through the process of bundling, after you get it all configured, you've got root access, you've got it exactly how you want, you use the bundle volume command, and that basically takes the entire system and breaks it down into a whole bunch of files that it puts into the temp directory. You then use upload, I think it's upload volume, which puts it into an S3 bucket that you specify and stores it on your S3 account. And then you use EC2 register, which takes that bucket name and a manifest file, which is created for you, and gives you back an AMI, which you can then use to, it's just that string, the string identifier of your new image that you just registered, and you can use that to run instances. Okay. So we're using MySQL for our production DB, and we set up a master slave, and we're replicating constantly from our master to our slave, and then we take snapshots very, very often of our slave database, so it doesn't impact performance. We then store those snapshots on S3. We mount an S3 bucket using a program called S3FS, which basically just maps it as a directory. We take the dump of the slave database, and we copy that into our directory that's mounted on S3. It depends on your perspective, actually. So for a 1.7 gigahertz machine, 1.7 something gigs of RAM, we pay about $80 a month. Which, if you went somewhere else, what was that? 80. These are finance. If you went somewhere else, I've seen comparable specs at $200, $300, $400 a month, and $80 a month isn't that much. When you consider the fact that, if you hit the front page of TechCrunch and you hit the front page of Dig or get Slashdot, we can immediately ramp up, as much as we need to. So, maybe there's a small premium on it, and personally I wouldn't run like my personal blog on it. I'd go get, these $15 VPS accounts. But the ability to scale up as needed, and particularly the ability to launch a new instance of my exact same production server for testing before I deploy to production, I'm willing to pay slightly more. Well, yeah, I guess it's a call everybody will have to make for themselves. It's if you need, yeah, it's a pretty cool technology. But if you don't have something that requires 1.7 gigahertz and that amount of resources, then it probably isn't the most financially viable thing to do. All right. Thank you.
That concludes this episode of the SD.RB podcast. See you next time.